There are four important families of distributions in econometrics. They are the most important one, the normal family. Then we have the chi-square, the t, and finally the f distribution, which is the topic for this lecture. So the f distribution starts with two chi-square distributions. So x is chi-square k. It's a sum of squares of k, standard normals. Y is chi-square L. K and L doesn't have to be the same number, but x and y must be independent random variables. Then the ratio of these two, x to y, appropriately weighted, so x over k divided by y over L, is said to follow an f distribution. And the notation we will use is the following. So it follows an f distribution with k and l degrees of freedom. We always do these numbers k and l in this order. K is the degrees of freedom for the chi-square in the numerator, and L is the degrees of freedom for the chi-square in the denominator. And the notation is then this. We say that f follows an f distribution k, L, or f distribution with k and l degrees of freedom. So here's the idea behind the f distribution. I have here a standard normal. I have 5 of them. They're independent. I have here the sum of squares of these 5 standard normals. So this number, 1.22, is a drawing from the chi-square with 5 degrees of freedom. Standard normal, standard normal, standard normal, sum of squares of 3 of them. So that number is a drawing from a chi-square with 3 degrees of freedom. So based on these, I can get a drawing from the f distribution with 5 and 3 degrees of freedom by doing equal to this one divided by 5, that divided by this one divided by 3. This will be a drawing from this particular f distribution. Notice that both of these chi-squares must be positive, so the f distribution can never give us negative numbers, and it doesn't have any sort of easy expected value either. We can look at the PDF and means and so on by creating a random variable. So let's do 5 and 3. So let's do f5 and 3. I'm not sure what to call it. 5 and 3 as a random variable. I think it's called the f ratio. Not sure in Maple. And you do the degrees of freedom 5, 3. No. Maybe f ratio with a capital R. Yep. It has a pretty complex PDF. So let's have a look at it. F5, 5 and 3, comma x. This is the functional form of the distribution. Mean is 3 actually. You can find variance if you like, but the final thing I just want to do is to plot the PDF 3 comma x, and in this case remember it cannot take negative values. We can see that up here as well. So let's go from 0. The expected value is 3, so let's go a little bit beyond that. Let's go to 8. And that's the f distribution. It looks sort of like the chi-square. So a nice exercise might be to plot this f distribution together with the chi-square with 3 degrees of freedom, because that also has the expected value of 3, and then you can see the differences between the f and the chi-square. Probabilities are almost always something you want to calculate from the right-hand tail. Not always, but most of the times. And most of the times it's the inverse problem that you want to calculate. So let's say that this is the PDF of f5,3. And I want to find this number here such that I have, let's say, 5% in the tail. We can do it using Excel. And the function you would use is then the f. You want the inv, the inverse problem, and you want the right-hand tail. You do probability 0.05. The degrees of freedom, you have to do them in exactly this order, 5,3. If you do 3,5, you will get a different answer, and this is 9.01. Here is just an arbitrary F table, and the F table typically works in the following way. You have one of the degrees of freedom in that direction, and then you have the other degrees of freedom in that direction, leaving no room for different probabilities. So typically for the F table, you need an entire table for every possible tail. So this table is precisely for the 5%, the one that we're looking for here. So DF1 was 5, that's the one we're looking for, and DF2 was 3. So we find here 9.0135, which is also what we found in Excel. Gretel, nicest, I think. F, degrees of freedom, 5, 3, 0.05, 9.01. EViews, you would do coef A equal to @ QF dist probability. Again, this one's the left-hand tail, 0.95. The degrees of freedom, 5 and 3. Show A, and we get the same result.